All right, so now we're moving on to parallel and perpendicular lines. We've been graphing linear equations and solving linear equations now for the last couple weeks. So now we're going to add in parallel and perpendicular. Well, parallel lines are lines that never cross. So I'm going to do the best I can. So that would be like a set of parallel lines. So parallel, just for some vocab here, are lines that never cross because they're going in the same direction. Okay, so they have the same slope. That's why they never cross. Perpendicular lines are lines that look like this, that form those 90-degree angles. So these are perpendicular. And perpendicular lines cross. They definitely cross. They cross that 90-degree deal. So they cross at 90 degrees. And their slopes are what's called opposite reciprocal. And we're going to do some examples of what that looks like, because I know you got to have an idea for that. All right, so continuing on with perpendicular, just to get the vocabulary down. So if one of the lines, the slope was, let's say, 2/3, then the perpendicular line slope, perpendicular, it's a long word, perpendicular slope would be what is called the opposite reciprocal, which means I'm going to take a negative, if a negative's not there, and then I'm going to flip it. So it'd be -3/2, just to give you in number form, okay? More abstractly, under perpendicular still, so perpendicular, the slope of one line equals A over B, so the perpendicular slope would be a negative B over A. So in other words, you're flipping it and you're having a negative. All right, so now let's do more than just looking at slope. So here, of course, this is where we big time get into this. Write the equation of a line parallel to x minus 2y equals 6, passing through the point -4, 5. So just like before, my first thing that I'm going to need to do is I need to put this in for my own benefit to slope-intercept form. So I need to take this equation and I need to solve it for y, because that's my lovely form. Because remember, I'm wanting to put it in the form y equals mx plus b. Because again, if I'm talking about parallel and perpendicular lines, slope is of the most importance. So to do this, then I need a minus x on both sides, and you guys are getting really, really great with doing that. So then I get -2y is equal to either -x plus 6 or 6 minus x. As you know, it doesn't matter. Next step, I want to divide everything by -2, and you guys are rocking it out at this. And so then you're left with y is equal to a positive 1/2 x, or x over 2, minus 3. So at this point, I know and I can identify my slope, my m value of this line is 1/2. Since I'm talking about parallel, we know parallel lines go in the same direction. They never cross, so they have the same slope. So I'm going to use this slope right here with this point right here to form my line. So when I do that, that means I've got to reminisce back to, so before I was wanted to get in slope-intercept form. Well, now since I'm given a point and a slope, I'm going to use point-slope form, which is y minus y1 is equal to m times x minus x1. So sometimes, if you need to, remember this is my x1 and this is my y1, just giving you an idea there. So I'm just going to plug things in. So I get y minus my y1, remember, is coming right up here. So my y1 is 5, is equal to, remember, my slope is here because we're talking about parallel lines, 1/2, parentheses, x minus, now it's a little tricky. There's my x1, but look, there's a negative. So it's minus a -4. So now I need to clean some things up. So then I'd be a y minus 5 is equal to 1/2. I want to clean up inside here, plus 4. Now, a lot of times we don't leave it in point slope form. We take it all the way to slope intercept. So we're going to solve it for y. So when I do that, I'm going to have to distribute. So y minus 5 is equal to 1/2 x plus what 4 times 1/2 is, which is 2. Now, and you guys have been doing great with this, I'm going to add 5 to both sides. And I am left with y equals 1/2 x plus 7. Now, before I stop, notice this equation compared to that equation, what's similar? Their slopes are the same. This part right here is the same. Their y-intercept is different, which it needs to be, otherwise it would be the same line. All right, now, I wanted to use one of these as a special case. What do we know about the line x equals 0? In other words, is it a vertical line? Is it a horizontal line? What's the slope of the line x equals 0? Well, if you need to go and do a quick little graph to think about it, so here's my coordinate plane. X equals 0 is right here, correct? Like, x equals 0 is there. Now, that means x equals 0 is there. It's all on the y-axis, so, and I'm going to draw it right beside it. X equals 0 is basically, it's right on top of that y-axis. So what's the slope of a vertical line? Well, we know the slope of this line is undefined. Well, now that gets a little tricky when we're talking about this. Because now we're like, oh, how do we put that into an equation? Well, what's parallel? Another equation that's going vertical. So to actually do this, this takes less work because you just are simply looking for what is the x value. That's all you're doing. So in this case, my answer would be x equals 4. Done. That's parallel to this line because this line is going vertical, has a slope that's undefined. This has a slope that's undefined. We can graph it real quickly. 1, 2, 3, 4. Bam. There it is, going vertical. That's the equation of x equals 4.